Hello, and welcome to Palisade Corporation's webcast, Mitigating Project Specification Risk Using At-Risk, presented by Dr. William McKibben, Consulting Financial Engineer, McKibben USA, LLC. My name is Jameson Romeo Hall, and I will be your host today. And I will be available to help answer WebEx technical questions by chat. If you experience technical difficulties joining this WebEx session, please dial 1-866-229-3239. Alternately, you can email technical questions to support@webex.com. At this time, all attendees are in a listen-only mode. Please note that as an attendee, you are part of a larger audience today. The attendee list is suppressed to maintain attendee privacy. We will be holding a Q&A session at the conclusion of today's presentation. You may ask an online question anytime throughout the presentation today by clicking on the question mark icon located on the floating toolbar in the bottom right side of your screen. We invite you to sit back and relax and enjoy today's presentation. I would now like to introduce your presenter, William McKibben. William, in a moment.
And are you now passing the screen to me?
You now have the control.
And if I, do you see my screen, or is there anything I should be pushing here?
Let's see. Click the Quick Start tab.
The Quick Start tab at the top?
Yes.
Quick Start tab, got it. And
now click Share
my desktop. Okay, and let me know when I'm up, and then we'll go from there.
We've got, there we are.
Okay, thank you very much, Jameson.
Thank you.
Appreciate it. And thanks for joining us for a presentation. My name is William McKibben. I live in State College, Pennsylvania. I'm a consulting financial engineer and risk analyst. I've been in the business now for over a decade, serving companies around the world, doing all manner of things associated with finance and a little bit of accounting, primarily involved with raising capital for deals and also assisting my clients with engagements that they are creating with other clients, contracting and so forth. So I've seen a lot of numbers over the years, and that's what I do for a living. And the name of our presentation is Mitigating Project Specification Risk Using At-Risk. I've been using at-risk for quite a long time, and have been a Monte Carlo simulator for well over a decade, and I've introduced this technique to many, many companies over the years, both as a trainer and as a consultant. And so it's my pleasure to be able to show an application of at-risk involving project designs and so forth. When they asked me to come up with a possible case study, one of the things I looked carefully at was what would be a good case study of the many things that I've worked in, which we could fit within 45 minutes or so, and also what we could make sure fits on a single screen. So what I'm going to show, what I'll be going over are matters associated with those kinds of things. Our purpose is here. And we're going to distinguish between two very different kinds of projects. The first are so-called fully specified projects, and that will be compared with what I call a quasi-specified project. Some of the issues related to the latter. And then I'll be introducing a case study during which we'll also be talking about various distributions and so forth that I use and rely upon, which are grounded in the literature, in order to develop projections and forecasts in support of quasi-specified projects. So projects. What is a fully specified project and a quasi-specified project? Well, you can look this over. And if you think about it, there is a difference between a project that might be called fully specified, where we know all of the requirements in advance, the timelines are known, the resources that are required by both the contracting party and perhaps the contractors are known, and the costs are understood. The problem or opportunity that the project is designed to address is validated by hard evidence, and efficiency is a key driver in these projects. So what kind of a project would this be? Well, for example, what if I was installing a McDonald's, a store somewhere, where we would do a site survey, we would understand requirements, we would have a very defined timeline on how we would proceed through the project. The resources would be well understood. We would know what training requirements, how many nails, how many boards, everything involved with putting that restaurant in operation together would be well understood. And of course, the costs associated with that would be an understood matter. We would validate the location. We would understand what the opportunity was that the installation was designed to address, and we would be very concerned about efficiency. Cost would be a matter. We would not want to see time or money wasted in that project. So that's one kind of a project. And there's other examples we can use of fully specified projects. Basically, these are the ones where we put the package on the table in response to an RFI or an RFP, and we tell them what we're going to, how much it's going to cost them for us to do what's been specified. Now, the other type of project is a so-called quasi-specified project. And these are the ones where, and many of us run into these, where we're not really sure what we're getting into when we arrive into the project. The requirements are frequently uncertain. We're not really sure what we're getting into. The timelines may not be clear. The resources available from the client and contractors may be unclear. The costs, therefore, are very unclear. You know, it's sort of like a project where you're putting a roof on a house, and the house is 40 years old, and the contractor is going to say, we're going to have to get that roof off and see what's under there before we really know what the costs are going to be or what we're getting into. So there are projects out there where we're not completely clear where we're going once we get into it, and frequently the problem or opportunity statement has not been validated. In other words, the client has a specific solution in mind, and perhaps it's a solution that addresses the wrong problem. So even as we go into the project, we may have to invest some time with the client to look at the specific issues that they are seeking to address, to understand better what the decision processes are and resources that are available to address that, and make sure that we don't do something such as install a CRM system to improve client management when the real problem is sales management and training for the managers. So these kinds of projects are out there, and we run into them, and inefficiency is inherent in these projects. So what are the concerns of both parties? Well, the client is usually looking for a number. They want to know what this is going to cost them, how much it's going to take, how many resources they got to put on the table, and so forth. But the contractor also has a perspective on this. We can let you look at this. Notice the word wiggle room. And so what happens is the contractor also is concerned that once I get into this, I may be locked down with an installation or some sort of a fully specified project that will need to be adjusted with some sort of a change. I'm going to need some wiggle room in my numbers. And so how do we address that? And that's what I'll be talking about in this brief case study about how we might approach providing some wiggle room in our numbers as our offer goes forward, our bid on a specific contract, and how we could present that to the client in a way that mitigates the risks of the uncertainty of a quasi-specified project. So, what's the problem? The problem is, how do we forecast costs for a project when the client requires more detail and specificity than we can offer, because we're not really sure where this is going to go? Where the business problem and opportunity requires validation before we can truly present what the exact solution will be. What about situations where decision-making processes are vague or changing? Perhaps a key decision maker who's doing who's designing or the concept of the engagement is scheduled to be replaced and within the year, and we know we're going to be working with new decision makers as we go into the project. And the resource commitments, perhaps, are completely under negotiation at this point. In other words, no one is really eager to say we're going to provide these resources, these people, these dollars, until we understand where we're going. But we do got to get the engagement started. So this is the problem from the perspective of both parties that we need to be looking at. So at this point, what I'll do is I'm going to be presenting some additional concepts through a case study, which I'm going to call the XYZ Corporation. This is an actual company I work with, and you'll see some numbers here. I've blocked out the names of all the parties so to protect the innocent. And this particular project was with a client I was working with, who's an intermediary who works with companies and helps them to design solutions to specific problems. In other words, they're specialized specifically in these quasi-specified project designs. And what was presented by management as the solution was a technology, a software technology installation involving both hardware, software, and training. The statement of the problem, however, required validation. There was going to be a strategic plan required in advance of actually implementing the project, and so it was likely that the direction of the project could change, and change orders were going to be required. General budgeting parameters were known. There was a number on the table that both parties could live with, but it was really not clear whether that was going to be a hard or a soft number. Matter of fact, it was clear there would be a soft number, that additional dollars or perhaps fewer might be required to meet the needs of that company. The general timeline was understood. They did have an idea that they wanted to get this done within about a 2-year period. So there was, but that number was soft again. Who knows how long these things actually can take until we know what the exact solution is that we're going to put in place. And scoping issues and disputes appeared imminent. And one of the concerns they had was scope creep was going to come into the project in various forms as they delved deeper into the true issues that were that the company was confronting. So as I meet with my client, which is the intermediary with the customer, they had designed a baseline cost analysis on a spreadsheet, Microsoft Excel, and this was a copy of that spreadsheet. There's some numbers here that they were looking at. We'll call these point estimates. We're all familiar with point estimates. Can we be sure any of these numbers are exact? Never. On the other hand, we have to start somewhere, and inevitably when we write a contract, there's got to be a number, a cost associated with it so that the decision makers and can approve or disapprove proceeding and signing the contract itself. These were some of the matters that the components, if you will, of the project that were being looked at and contracted for: a strategic plan, some accounting interfaces, a data warehouse was a part of it, all the typical things associated with a technology installation, software and training and so forth. So this is the spreadsheet that was sent to me. They said, okay, what can you do to help me soften this? What can we do to make an enclosure to our contract? How can we use this? What can you do to add a layer of value for me so that I have that wiggle room that I'm looking for? So when I get a document like this, the first thing we do in risk analysis, we're going to do a Monte Carlo simulation. And let me just mention, I'll be using at-risk. I won't be teaching at-risk, but if you have any questions about how to use the software I'll be showing here, get in touch with Palisade. They do have training programs designed to bring you up to speed on the exact tool itself and how to use that in an application such as this. But we are going to be using the software. And when I go to my assumption cells, which are these data items here, in other words, a cost, say, for the strategic plan is $135,000. This is all in thousands of dollars. Okay, that's a point estimate, a number. And the total strategic plan was estimated then to be $135,000 worth of work, probably mostly labor, some travel, and so forth. And other costs are listed here. These are what we're going to call the assumption cells. And what we're going to need to do is put some sort of a stochastic distribution over each of those. Okay? And then we're going to tally those up as our forecast cells, and we'll be working with those. So if I'm looking at assumption cells, how do I determine what kind of a distribution goes on that? And this might be the most important slide that I have. And the first thing I always do is I say, do you have data? And if so, who's got it? When can we meet with them? Because if we have data, we can do a data fit based on that empirical evidence that's going to be the most reliable kind of evidence that we need to support a specific distribution. Now, what if they don't have data? In this case, they did not. They say, well, I then ask, well, okay, I understand we don't have exact data. How about some parameters? Can you tell me something about your experience with forecasting numbers for, say, a strategic plan or all the different elements of the contract? Can you tell me some pieces of information that I might be able to employ to create a distribution which would fit with what you're providing? Perhaps something as simple as a standard deviation around which the frequencies would fall, or perhaps an understanding of the mean, any of the descriptive statistics. What can you share with me so that I can see if I can fit something to that data? And there's always a chance when parameters are provided that we'll be able to fit a distribution to that using at-risk as the tool to get to that. Now, parameters, in this case, they did not have parameters to provide. Parameter information frequently can be provided. If one is looking at, say, credit card transactions for gasoline in the last month, you're probably not going to get data. You're going to get parameters. That would be an example. In this case, they did not have parameter information. So we reached down a little further, and I would then say, okay, I understand we don't have data and parameters. What kind of expert opinion can you offer to me based on your experience in running your company? You've obviously had a lot of clients over the years. What is your experience with this? And in this case, the client said, well, that I can provide, and that is we've generally experienced, and in this case, I'm going to give you a round number. I'll show you the actual solution that I came up with them as we finish. But for now, let's just say they said plus or minus 20% from our point estimate, a mean. In other words, when I said $135,000 for the strategic plan, that cost could probably be run somewhere between 20% less than that or 20% more. So what are they providing me? A scenario. I now have the elements of a scenario analysis, best case, worst case, most likely outcome, which is certainly a way to get started on a distribution overlay for that particular forecast item. Now, I just want to mention, what if you don't have an expert opinion such as that, some way of creating fitting a distribution? Well, the only thing you then have left is a mandate, and that is when management says, do it this way. Here's the distribution. And as long as you footnote that, I can live with that. I mean, I'm just the analyst. They have to live with the results. I do footnote mandated information. And I'll mention there are clients out there who do mandate exactly how certain distributions have to be fitted for whatever reason using policy letters and so forth. So you do have a last option of a mandate. And if we don't have any of these four, then we really don't have the ability to know what to fit over a particular assumption cell. So this is my methodology. So I mentioned that they provided scenario information, plus or minus 20%, worst case, best case, most likely. What we're really talking about there is a triangular distribution. And triangular distributions are something that the literature supports use of in project management. And those of you who work with distributions regularly are going to be very familiar with the triangular distribution. There are some other similar distributions, the beta-PERT, and there's also an alternative triangular distribution truncated at 0. But a triangular distribution is simply a very easy way to fit an artificial picture of what what a scenario looks like. Now, there are some other distributions supported by the literature. And if anyone has any questions, let me know, and I can get you those sources. One of them is a log normal distribution, which is a positively skewed distribution truncated at 0 on the low side, and with a long tail. It's a single tail distribution that reaches to infinity on the right side. Why would that be a useful distribution? Because costs don't ever run below 0, or they shouldn't. In other words, what is a negative cost? And so a normal distribution, which is a two-tailed distribution running to infinity on both the positive and negative side, probably would not be a useful distribution for project cost analysis. Log normals are frequently used, and I'm going to mention in the actual analysis I did for them, which I'll show at the end, I used a log normal distribution. There's also a third distribution, which the literature supports use of, called an inverse Gaussian distribution, which is an alternative continuous distribution with support for truncation at 0 and infinity on the single tail. Probably not used very often, but if you do get parameter information, which includes a location and some other rules, then you might consider that. In general, however, we generally use a triangular or a log normal distribution for most project cost distributions. What is the triangular distribution? It's going to have a worst case, best case, most likely outcome. We're going to fit that scenario analysis to that. A log normal distribution has a positive skew. In other words, it's going to be leaning to the left. It's truncated at 0. Very similar to a normal distribution. However, it does provide a better description, replication of what cost analysis might look like. And the third possibility, if you need a graphic of it, is the inverse Gaussian, which is, again, an alternative single-tail distribution that's frequently supported by the literature. And again, it would be parameter-driven if we needed to turn to that. Okay, so we've talked about the distributions. What I'd like to do now is to go ahead and turn to our case study, and I'm going to actually bring up an Excel spreadsheet that I hope you can see, which had that single spreadsheet in it. And I'll just mention I chose this particular case study because it does fit on a single screen. Most of the projects which I provide support for are huge. They're huge spreadsheets that cover many worksheets and possibly workbooks. And so I chose this relatively small project because I could portray it on a single screen, and it fits. So it's a relatively small project at $2.8 million. But some of the things I'm talking about here could be applied to a much larger model if you needed to apply them. So we have this spreadsheet with the cost that they were projecting. Somehow they calculated this. And the first thing I would do just to set up the model is I'm going to replicate this spreadsheet, which I did here, and I'm going to go ahead and convert them to the actual numbers by multiplying them times 1,000. So what you see is that instead of 135, I now have 135,000. And actually, I'm going to go ahead and make another copy of that just so I can work with the model. So I now have an exact copy of that as a third tab on my Excel spreadsheet. And I hope you all can see this on your screens okay. So let's go to our first cell where we need to come up with some sort of an assumption cell. And to do that, I'm going to go ahead and highlight the cell. I'm going to go and choose an Excel Palisade distribution, an at-risk distribution. And again, if you have any questions on some of the things I'm racing through here, Palisade does offer courses in this. And I've decided to use a triangular distribution based on that guidance I received, the expert opinion, about plus or minus 20%. And I'm really doing that so I can make this exercise flow a little easier for our teleconference. In truth, I probably would delve a little deeper into, I would definitely delve a little deeper into each one of the categories. What I'm going to do here, though, is apply a triangular distribution to each of these, plus or minus 20%, and let's see what we get. So I'm going to drop down to a risk triangle, and bear with me as I go through this. And I'll choose that. And the first thing I've got to do is come up with my links to the minimum, most likely, and maximum outcomes. So to do that, I'll go ahead and do an Excel cell reference to the previous table. And so if we take that number, and I'm going to multiply that times 0.8, that's going to give us a minimum of approximately, or about 20% below the mean. And then for the mean argument, I'm going to choose that same cell, and we won't be changing that. That'll be our most likely outcome. And then for the high side, I'll go ahead and link again to that cell. And this time I'm going to multiply it times 1.2. Okay. So you can see we have a mean of 135,000 by linkage to the previous worksheet. We have a minimum of 80% or 20% below that mean score, and we have a maximum of 20% above that. Now, I'm just doing this for the exercise. Again, we would want to understand those matters much more deeply before we just put those numbers in. Okay, and now what I'd like to do is, now that we have this set up, I'm going to go to at risk. I'm going to go ahead and see if it works, because we now have a cell here, risk triangular, with the parameters we included. And so I'll go ahead and try the F9 key. And you can see that I am getting variance in that number based on the parameters that we put in. As you can see, it's cycle. I'm pushing the F9 key, and so it's recalculating. Okay, so I do have something that's now working. So I've now defined a plus or minus 20% for this particular cell. What I'd like to do next is to go ahead and copy that cell, that tool, or that formula, into all the other cells. And to do that, I'm going to literally just do copy and paste. And bear with me while I go through this very quickly. And this could actually be how you would do it in a real case. Of course, I'm speeding things up here. Again, I probably would look at each of these much closer in a real case, so bear with me as I go through this, and hopefully I haven't missed any. I won't miss any. So actually, I'll stay on the same column. And here, Jameson, if you eventually see that I missed one, you might alert me. And we're almost finished. One here, and now we have here. Okay, I'll go across here, and now here, here. You can see this is very easy, this process of copying cells or distributions onto other cells. Okay, and now again, going back to my single step tool, I'm going to go ahead, and you can see I'm now getting variance in all of the numbers based on the distribution I've applied to over those. And in this case, a very simple plus or minus 20% from whatever the point estimate was. Okay, so we now have assumption cells in place for all of the numbers that were provided to me. I've softened those numbers with stochastic variance. Next, we need to go ahead and put in our output cells. And to do that, I'm simply going to highlight the cell and choose it as an output. Notice we have a risk output for that particular cell. And again, I'm going to copy that, and I'm going to begin copying that output formula into all of the output cells. Oops, I'll skip that. That should have been a copy. Go back to that. And I'm doing this with one hand, which is part of the problem. Okay, and then I'm also going to put a forecast cell down here, an output. So good. We'll copy that, and now I'll paste that across here also as well. Okay, so everyone should be able to see what we did, and that is we simply applied our output cells to each of these, and you can see that the model is set up. And let's go ahead and do our single step tool again just to confirm that our model is working. And you can see we are getting some uncertainty, and we are seeing activity in each of these cells as we go through it. Okay, so we've now set up an Excel worksheet model. We're ready to go. We're ready to run a simulation. And so let's do that. You'll notice that I have preset my simulator to 10,000 iterations. We could talk about how many actually should be run. That's a separate question. But just to make sure we have enough, I went ahead and selected a high number. Probably would set up, we would probably set up a control factor on that to make sure we reached a certain level of confidence. But for this matter, we'll just run it. So I'm going to start the simulation. And we can see the simulation is running. I hope you can see that on your screens using WebEx. It'll be running 10,000 trials, and it will soon be finished. We're about 2/3 through now. It's very fast. Okay, and now we have simulation run. I'm going to go ahead and say, let's look at the results. And so let's choose a cell. And you can see that we have now got forecasts, in this case for the total cost of the project. we're showing that the total cost is projected, based on the assumptions we use, is somewhere between $2.73 and $2.9 million. And so we have definitely softened the projection on this using the assumption cells that we have. We could go to each of the other areas. That's not a good example because there was no intermediate factors. Let me choose, say, this one. This would be for the partnership accounting, I suppose, or alternative investments, whichever that is that goes across. And this would be the cost on that particular project, that portion of the project. We'd be projecting somewhere between $545,000 and $654,000 would be the total cost of the various things we would be doing to install the, I suppose, what's called the InvestTrans solution. Now, again, I just want to reiterate, I chose a plus or minus 20%. I actually do look at each of these cells more carefully than that to make sure my assumptions are valid and are defendable in the final report that I generate. So you can see now that we do have generated a stochastic analysis that's interesting, both to the person making the bid and also to the client, where they can see where this thing could show up, where this thing could result. Okay, so what is the next step? Well, we've got our report, we have the information, we now need to report this information to everyone so that they can use it for decision making. So I'm going to go ahead and choose an Excel report, and I've pre-selected some results that I want to include in that report. It's now running. And on a separate workbook, you can see the report compiling, the various tabs at the bottom. We're going to look at this for a moment. It's almost finished. Okay, so what have we got in our report? Looking at the report data that we have, it's in an Excel spreadsheet, and we could actually go through each of the outputs that were generated, various inputs and so forth, and see what the projections are and the descriptive statistics in support of those. And just to choose one to look at a little closer, I'm just going to take the total cost of the overall project. We would definitely look at each one of the cost categories individually in a meeting in consultation with the client. But in this case, again, we're seeing that cost at somewhere between $2.73 and $2.9 million. We can now share with the client various descriptive statistics in support of that finding. And perhaps most interesting, we now have a graphic that we can copy and put into a final report in some format. So what I'm going to do next is show you what I do with this kind of information, because one of the things I like to do is to get it on the record. So there's no misunderstanding about what I'm reporting. I want to make sure everyone is clear that what my findings were and that there is a historical document to support it. And so I've created what I'm calling the XYZ report here, in which I eliminated some of the names of the innocents, so you cannot see that. But what I then do is prepare a report for the client, reporting what my findings were, what the projections were. I'll include copies. In this case, I included a copy of the total plan amounts, and also advised that if they had questions or required expert explanations of my findings, I was available to provide that to either them or their clients. So I've provided a report that details what those findings were, and attached to that report are about another 30 pages of the detailed information that came out of my at-risk analysis. And I actually put this in this case, what is a 33-page report, so that we can have that and go over together, and perhaps they would want to share that with the client. All the information that went into creating the analysis is then available, and we can have a informed discussion about what I see happening with a particular project. Now let me mention the data that the results that I'm showing here are not similar to the triangular distributions I used. In fact, what I used to create this were log normal distributions for the assumptions. These are the assumption cells, and I did have better parameters to work with than simply a plus or minus 20%, depending on what the different category of costs were. And so I used the client's experience data to generate these results. And so that is why the number you see here in the final report is slightly different than what we showed in the analysis we did as a case study. What is my client interested in? The person making the bid, they like the idea of this tail. They like to know that, you know, if the costs were to go, and they certainly don't want that to happen because it creates dissatisfied customers, but they like to be able to say, well, we did alert you that there was some possibility, albeit 5%, that the cost of this project could be quite a bit more or less than what we were showing as our bid cost on the project. So this is how I then, or one way I might generate a report and get that to the client for their use. So with that, I've walked through a case study where we've talked about how we might approach a project bid for a client so we can soften the numbers, and how that reporting might be used to soften the entire contract engagement. Just so you know, my client actually uses these reports as an appendix to his contract agreements. So it is very valuable to him, and I have a good business working with him on the various projects that his company is bidding on. So with that, I'm going to ask if there are questions about this very small, simple case study, and most importantly, how one might use at-risk as a tool to create a stochastic analysis for project bids. And if there are any, I'll be glad to entertain your questions.
Oh, sure. Let's wait a minute. Maybe some will come in.
And if there's not, that's fine. Let me mention also, while I'm on this slide, if you have any questions that you'd like to address to me at private, my email address is there. I also have a website at McKibben USA. You can learn a little more about me if you're interested. Or just call Palisade. They know how to get in touch with me. But I spend most of my day interacting with other analysts on all kinds of questions, or interacting with students with their various questions, you know, and the things that they're working on. So I'm always excited to hear from someone about, well, you know, can you share with me this, or what about this? So I am available. I am in the business, and I'm always eager to link up with people who share my interests in simulation analysis.
We'll leave that slide up for a minute.
Sure.
And we'll wait a minute, because sometimes
And if I don't get a chance to say it, I appreciate you all listening to my vignette about how to do this. I wish I could see everyone eyeball to eyeball, because I so much enjoy meeting people personally.
Me too.
I guess you didn't have to listen to any of my jokes along the way either. So I'm friendly and harmless, and I certainly wish maybe in the future we can come up with a way to do this where we see everyone's headshot as we interact.
Oh, that's coming. I
know. I'm prepared for that. I know that Palisade is working on that as we speak and evaluating the technology, so that perhaps anytime you call anyone, including Jameson at Palisade, you might be looking at their face probably in the near future. We'll all have to wear neckties, Jameson.
Yeah. We'll have the clip on that we can just throw on as soon
something like that. Yeah.
Let's see. Well, as we said before, you can email William. You see his email address right there. Also, this presentation is going to be archived on our website. You can watch it for free at any time. In the next couple days, probably by next Monday, we'll have it set up. And I'll send out an email reminder with the link in the email, so anybody, they can just click right on in the email and go right to this.
One important question I sometimes am asked, if I could just go ahead and answer one. May I do that, Jameson?
Sure, certainly.
One of the important questions I would have looking at this is, how can I justify a triangular or a log normal distribution? Because based only on on expert opinion. And one of the things you might need for your personal archives, if you're in project bidding, is you might need to have on hand the various literature items. There's a RAND study that supports the use of triangular distributions that is seminal. There's other research that is very convincing in support of the log normal, and there's some research in support of the inverse Gaussian distribution. But those articles can be very helpful to have on your hard drive when someone says, well, why? And then you can hand that. I sometimes will have these available so that if I need to, I can email them immediately or hand them out, and then that clears the question up. My use of this for project bidding is grounded in the literature, and there is extensive research supporting the use of triangular and log normal distributions for this purpose. So I can share those with anyone who might be interested. And of course, linked to that is it's all about the data. We have to love where our assumptions come from, and so anytime you're briefing something like this or presenting, you must be prepared to explain how and why you used a certain distribution in support of your analysis. Even if it means simply putting a footnote that says, well, this was mandated by management or policy letter as the method of choice for this particular company. But that is a stand-up issue that has to be discussed, or you must be prepared to discuss. And I have some documents that might be of help to any analysts who would like me to share those with them. Thank you, James.
Great. Very good. Well, I think we can wrap this up.
Good.
This was fantastic.
Well, thank you so much for the opportunity, Jameson, and please pass on to all the executives at Palisade that I certainly enjoy doing this, and if I can answer any questions for your clients or anyone there, please let me know. And, of course, anyone on this conference call, feel free to send me an email or give me a call, and I'll be glad to have a chat with you. Thank you very much.
Thank you.